What pressure would be required to contain 100 grams of SO2 gas in a 25-liter container at a temperature of 100 degrees Celsius? So to solve for the pressure here, we can use the ideal gas law, which is PV equals nRT, where P is the pressure, V is the volume, N is the number of moles, R is the ideal gas constant, and T is the temperature. So we're given here the number of grams, the volume in liters, and the temperature in degrees Celsius. We just have to convert the temperature into Kelvin. So this is just equal to 373.15 Kelvin. So to find the pressure is just equal to number of moles times the ideal gas constant times the temperature over the volume. We need to find the number of moles first. We're given here the number of grams, the mass of SO2 gas, so we need the molecular mass of SO2. So we just have to divide the given mass, which is 100 grams of SO2 gas, by its molecular mass, which is just equal to 64.066 grams per mole SO2. Grams here cancel out, so we're left with number of moles. So the number of moles SO2 is just equal to 1.561 moles SO2. And now we can solve for our pressure. We can just plug in all the values given. 1.561 moles times 0.0821 atm liter per mole Kelvin times the temperature, which is 373.15 Kelvin, over the volume, which is 25.0 liters. From the calculator, we get 1.91 atm. So number of mole units here, the mole unit will be cancelled out, liter as well as the Kelvin. So we're left with atm. So the pressure here is equal to 1.91 atmosphere. What pressure would a sample of gas have if the volume is 10 liters, the number of gas particles is 0.10 mole, and the temperature is 500 Kelvin? So again, using the ideal gas law, PV equals nRT. Pressure is just equal to nRT over V. So we don't need to convert anything here. So pressure is just equal to the number of moles, 0.10, times the ideal gas constant, 0.0821 atm liter per mole Kelvin, times the temperature, which is equal to 500 Kelvin, over 10 liters. So this is just equal to 0.41 atmosphere. So that is our pressure. What volume would a sample of gas have if the pressure is 8.2 atm, the number of gas particles is 2 moles, and the temperature is negative 73 degrees Celsius? So let's convert the temperature first into Kelvin. So that is negative 73 degrees Celsius plus 273.15. So our temperature is just equal to 200.15 Kelvin. So the volume would be V equals nRT over P. Now we can plug in everything. That is 2.0 moles times 0.0821 atmosphere liter per mole Kelvin times 200.15 Kelvin over the pressure, which is equal to 8.2 atm. So the volume here is just equal to 4.0 liters.